Hello everyone. My name is Prasanna Kumar. I'm a first year student. I'm doing my master's in civil engineering with project management specialization. So today I'm going to represent in this presentation. Thank you.
Yeah, hello. I'm Mohammad Iftekhar Hussain. I am doing my master's in genetic engineering and I am in first year. And today I am going to represent the presentation.
Hi everyone, my name is Gagandeep and I'm a second year master's in civil engineering student. So my specialization is general engineering. So today I'm going to present this presentation.
Okay, hello everyone. My name is Mohammad Hussain Wajeti and I'm studying mechanical engineering and I'm in first semester. And I hope that we present in the best way. Thank you.
My name is Okosi Simitoya of first year civil mechanical engineering. I'm doing a video presentation concerning the space shuttle disaster.
To start with, I would like to share the summary of our case study. The Space Shuttle Challenger is exploded on January 28, 1986, in just 73 seconds after the launch, which resulted in the killing of seven crew members, which were on board. And the main cause of the explosion is failure of O-ring due to the unusual freezing temperature. There are some engineers raised the safety concern regarding the launching of the freezing temperature, but the NASA management proceeded the launch under pressure. Some of the key issues were a communication breakdown, organizational pressure, and violating the safety protocol, which led this incident. Now coming to the next slide, I want to discuss about the biases in this case. There were actually three types of biases, that is confirmation bias, schedule bias, and group thinking in our case. So coming to the confirmation bias, management violated and ignored the safety concern and were confident for the successful mission because their past missions were successful despite having the issues in O-ring, and they also launched in low temperature, which were successful. Coming to the scheduling wise, there were a pressure from the high level management to meet the deadlines, which influenced the decision making and creating a schedule bias. In group thinking, to avoid the conflict at the last moment and the pressure to support NASA's goal, engineers were forced to speak up strongly about their concern. Now, in the next slide, I would like to discuss about the system issues with NASA. There were mainly three issues in our case study, that is communication breakdown or organizational culture and lack of a robust safety culture. In communication breakdown, there was a communication gap between the NASA management and engineers, which led to the bypassing or ignoring the critical safety protocols. Coming to the organizational culture, they mainly focused on launch schedule and matching public expectations rather than addressing the technical issues involved in the launching process. Lastly, there was a lack of robust safety culture. That is, their safety protocols were so weak, which resulted the non-technical management managers to rule over the engineers concerned. And thank you. The next will be continued by Victor.
Okay, thank you, Prasanna. Here I will represent how the course materials are relevant with this case. Here, the engineer have a primary ethical responsibility to ensure public safety, which was compromised when safety warnings were ignored. Ethical practices providing value to technical expertise, ignoring engineers' warning lead to disastrous consequences. Ethical decision making requires resisting pressure to prioritize deadline over safety, sometimes that was not upheld there. The disaster led to challenges that emphasizes ethics and safety in engineering decisions, making it a landmark case in engineering ethics. In the next slide, I will explain how the O-rings are affected by the temperature. First, temperature versus compression curve indicates that how the O-ring lose their ability to recover their original shape in cold temperature. Then, elastic module versus temperature illustrates that at lower temperature, material is less stiff and lose its flexibility and seal. Then failure rate versus temperature, despite that at lower temperature risk is higher, which indicates that colder conditions greatly increase the risk of material failure. Finally, leakage rate versus temperature, it indicates that at lower or cold temperature, leakage rate is high as compared to higher temperature. Due to this reason, O-ring fails. And after that, Gagandeep will explain the rest of the presentation.
Okay, thank you, Ipsika. So in this slide, I'm going to represent about the some key lessons that we learned from this case. So the first one is engineering concerns. About engineering concerns should be addressed as the primary safety issues, not dismissed due to the schedule or budget pressure. So we always have to take care about the primary safety first, not about the pressure that the management is putting on the engineers in this case. So this case or disaster illustrate that the importance of the open and transparent communication among the organization. So we always have to take care about the communication. So in the third thing is risk assessment and decision making should have strong check in place to ensure important safety concerns are not overlooked. So it is an important to proper check each and every crucial components of the aircraft as well as the other machinery so that this type of disaster won't happen again. So coming to the next slide, it's about the future action and the prevention that we have to take so that this type of disaster won't happen in the future again. So we have to enhance our safety protocols that required through documentation and rest all engineering concern, especially under unusual conditions. So we have to enhance our safety protocols so that this type of disaster won't happen again. So we have to create a culture where engineers feel supported and can communicate it with each and every member in the company so that they can express their views about the technical issues and can escalate their safety concerns without any fear. And in the third one is regular trainings. We have to provide like in companies and the big organizations have to provide the training and the regular trainings to the each and every individual member in the company. Either those are engineers or the management, they have to provide the regular training to the company, regular training in the company so that this type of disaster would not happen in the future. Organization also have to create some whistleblower rules so that everybody can raise their voice for the wrong thing. So in the next slide, we are representing some references about this presentation. And thank you everyone. Thank you very much.